Hey, hi everyone. Good morning. Hope everyone is having a good day. Today is the third day of week 6, where we will see some introduction to open source LLMs, where uh, we will see what they mean, what makes them better than the closed ones, and how we can use them, their architectures, and their benefits and challenges. And then we will have also a short demo where we will use an open source LLM that's deployed on Hugging Face. We are going to be using actually the DeepSeek model to have a demo session where we will see how we can use this open source model from Hugging Face to build a RAG app and see it respond to our queries. So as usual, if you have any questions, if anything is not clear, please make sure to ask. Raise your hands or just speak. Can you see my screen? Okay, good. So let's have just this introduction. So we're not going to be diving deeper. For the introduction, let's start with what they are. What are open source LLMs? So we know LLMs, we know AI. We have been working with a lot of LLMs recently, and what are open source? Like most of them that you find online are closed. So what are these open source LLMs or large language models? So they are characterized by publicly accessible code. So you can find their code on GitHub or other platforms, and you can see underlying architecture design and then trained weights. So pretty much you can see the architecture and the code that they have been trained on and their weights. So that means they are open to the public and they are open source. So this means you can have the freedom or the option to do the research on it, utilize it, deploy it yourself, examine and enhance the weights and other architectures, and distribute these models without typical preparatory constraints. So they are practically, of course, there are some license issues that you have to take a look at or take a look into before you start, but most of them are free and freely available to you, the developers and researchers, to work on, to take a look at and enhance and work with them yourself. So their operational mechanics, of course, this is also for every the first one, pre-training, is for every LLM. So they are trained on intensive training dataset that could be billions or trillions of parameters, like billions actually of parameters or tokens, billions and trillions of words. And they are, so what make them open source is open release. So the core component or the model component, the neural network design, their weight they are trained on is released under open source or open licenses. And of course, what makes them unique is you can, of course, like some of the closed LLMs models are, you can have them pre-trained on your model. Oh, sorry, not pre-trained, fine-tuned on your dataset for particular needs. But what makes this different is you can do it yourself, and you have already the knowledge or the code of like the previous pre-trained model. So you can fine-tune this pre-trained model, like adapt based models on a specific dataset for your particular needs. And of course, you can deploy, you can adapt these models, integrate into your applications. You can use it via API, or you can host it locally as well. Of course, for the API, you have to use some platforms, or you can host it yourself and use it via APIs. So that's pretty much what open source LLMs are. So they are already pre-trained on a vast, diverse, publicly available. So it's not 100, I would not say it's 100%, but most of the data that they are trained on is publicly available text. And like, I think this is some of the issues that you can see from the closed models. You don't know where they have trained their data on, especially from, the ones that are really good on coding. Of course, there are a lot of lawsuits that are coming, I believe, because they have trained on data that are, not, I would say, not publicly available, or do not have authority over them. But basically, for the open source, they are trained on publicly available text, so they are open. Okay, so this table actually summarizes what some of the features we have here. 7 features. For the first, the 7 features, what open source and closed source LLMs are different, or they are pros and cons, I think you can say. So for accessibility, so you can access their code, their weights, you can use them, you can study them, you can modify them, you can share them, you can deploy them, and so on for the open source. But for the closed ones, user is subjected to owner's terms and condition, and the code is not publicly available. For the customization, you cannot. You can, like I've said, they have APIs that allow you to fine tune their models on your, data set for specific use cases, but they are limited, very limited customization options for the closed source. And of course, their underlying code is not accessible. But for the open source, they are highly flexible, adaptable, and you can fine tune them for your own use. For the community, of course, for the open source, the community is responsible. Of course, not always, but people contribute to the improvements, bug fixes, and enhancements. But for the closed ones, the internal development team is responsible for it. For licensing and cost, they're generally free if you actually use them, especially. But for the closed source, it requires licensing on subscription fees. For transparency, open source are fully visible. You can see their code, their data, and like their weights and so on. So it fosters trust. But for the closed source, they are basically black box, so that you cannot look into like their internal working, their data that they have been trained on, and so on. And for security, can be deployed on premises for data control, community aid, in faster fixes. But for closed ones, internal security measures are taken, so it's highly secure, but less user control over their data. For the support, of course, like we have said, it's primarily supported by the community. For open source, the documentation and resources also are supported. But for a closed source, it basically have professional support, and they have professional dedicated support team and regular updates from their internal development team. So that's the open source is more basically heavily dependent on the community, while the closed it depends on the internal developers mainly. So why? Okay. So in this case, or in that case, like, why would you choose open source language models? So what are the advantages and the benefits? So the first one is trust and transparency. So since you have access to the full code, the weights, like the data and so on, the modification and the security, like identifying, you can identify resolve biases, and you can actually trust that your data is not going to be leaked, especially if you deploy it yourself and pre-train it, or fine tune it and so on. And the second one is customization and flexibility. So for fine tuning on a specific data set, which is crucial for tailoring solution for unique industrial needs, it's highly adaptable. The open source models are highly flexible, and you can actually do it yourself. For cost effectiveness and no vendor lock-in, so it eliminates the licensing fee and the subscription fee, and reduces the long-term operational cost and prevents this reliance on a single external provider. So if OpenAI goes away, a lot of businesses could suffer because they are heavily dependent on them and so on. But if you have, of course, it has cost, like especially if you use it locally, it's computationally intensive and so on. So like, of course, for I'm talking about the good models. For small models, it might not be that much of a problem, but yeah, at least you're not going to be dependent on a single provider. And for rapid innovation and community support, so here the community is more responsible for like the contribution, improvement, bug fixes, and new features, which accelerates the high advancements. And actually, you will learn if you follow this open source, like their source code or their GitHub or so. You could actually learn a lot, especially for the new. When a new feature is added, you can directly see how they did it, and you can actually learn and use it for yourself. Data privacy and security. So this is the major one, especially if you are planning to train it or to use it for local, for your own company or for you on your personal data set. So the option to host on premises or locally retrain sensitive data within controlled environment and allowing custom security implementation is very, very sensitive, especially if you are working in a company where sensitive data is there. I think the open source LLMs offer a good option. And if, of course, for financial data as well. So the ability to deploy on premises is crucial for regulated sectors like finance, healthcare, especially. These two are very sensitive in the case of their data, the data they handle, because finance is a very sensitive data, and healthcare, like the data of your patients should be handled with care. So it ensures data sovereignty and compliance. So it's really good. And of course, like I have said earlier, like smaller, lightweight open source models can run on CPU, smaller, but they're not as good because, like Gamma from Google and Pi is free. Like so that you can use it on device applications. Actually, I think you can use Olama to explore these models as well. And like some of the models are even so small and so efficient that you can use it on your modern smartphones as well. So this expands the AI deployment probabilities to resource constraint environment. Yeah, okay, so how is it going, guys? Is my audio clear? Is everything that we have talked about so far clear? Okay, good. Yeah, so of course, I'm not going to go deep into this for now, but since it's introduction, but how do they function, like especially the architecture side? So the foundation of any LLMs is the transformer architecture. Now, of course, for the models that we are going to be talking about, which enables parallel processing of text sequence. So, as we have said earlier, it's pre-trained on enormous, like billions and trillions of words, uh, which is diverse data set to learn general patterns. So the original model that's not fine-tuned has a general knowledge because it's trained on a vast category of like data sets. It could be books, it could be research, it could be like a lot of things. So since they are trained on like a vast data set, they will have a good general knowledge. And then you can take, I think you have like we have pre-trained, like we have used pre-trained models and fine-tuned them in, I think, week 3 or week 4 project. So now that I remember it, I don't think this is going to be a new idea for you guys as well. So we have used, like BERT, I think, in order to use it for name recognition, name entry recognition purpose. So like we have used the pre-trained model and fine-tune it on our, like labeled data set. So that's pretty much what this slide is discussing. So it's pre-trained, so it has, like general knowledge. It understands words. It understands, like things like that. And after you have this general knowledge, it knows grammar, it knows language pattern, and it knows factual knowledge. You take that and you train it on a smaller specific data set for your use case. It could be for your industry. It could be for your specific work or your data in order to help the model adapt to your particular application or domain. So that's how like it functions. So some of the key architectures are like you can take them as in order. So the first one is embedding. So this converts. I think we have also seen this yesterday. So it takes the plain text and it converts into vector embeddings or vector representations. And then we have the transformer layer, which is the computational block, which is the main block, the core, and self-attention mechanism. So this will select the word with the highest importance or weight. So weights the importance of the words of the different ones in the input sequence. And then we have the positional embeddings, which tries to maintain understanding of word order, the order of they should come and go. And the key value cache is just stores previously computed key and value pair. For inference speed optimization, multi-query reduces, like if you use multi-query, it reduces your memory consumption and computational overhead. And we have the normalization layer, which stabilizes training, activation, which is just, I think, on the next session on open source, we will actually see them in detail. This is just introduction, so don't worry about it, okay? On the next one, we will see them in detail for each one. And we have the activation layer, which is introduces linearity, and final dense layer, which maps the process presentation to vocabulary size, and parameter counts the number of weight and biases. I think actually some of the words that we see here, we have actually discussed or seen them or experiment with them on week 4. So they're not new words, but we will actually see them in detail in the, yeah. So, I just tried to list some of the most famous, I would say, models, open source models that you can find right now. So, These are mainly driven by Meta or Facebook, Google, Microsoft, Mistral, and TII. But from Meta, the Llama function, the Llama model is, I believe, have been in the competition for longer and is improving a lot. And it's very powerful, high performance. It supports multi-language. It has a large context window, like 128,000 tokens. And for the Mistral, I think it is from French. I think this is one of the only models from that's really good from Europe. So it's very efficient. Actually, it's very smart. I don't know if you have used it, but it's really good. It's lightweight. That's what's really impressive for me. It's featured like sliding window attention and so on. So they used to give free APIs, actually, but yeah, yesterday when I tried to use them, I think, I don't know, maybe they have lifted the free APIs, or I'm not sure, but they're no longer provided. But they used to provide 100 million tokens per month for free, and that token is going to be updated every month. So that was a very generous limit, actually, for free. So I don't know why, but when I tried to take a look, I couldn't find it. But yeah, and Falcon, which is I believe from Saudi Arabia, or I think it's from the Middle East. It's heavily trained on like research papers, and it focuses on efficiency and scalability with multi-query, multi-group attention. And Gamma from Google is lightweight. It's very small language models, but it's optimized to be run on CPU and on device deployment. Pi is also very small and is designed to run on CPU and devices. It's from Microsoft, and its compact size with significant power runs on mobile devices, the mini one. And BERT from Google as well is early and influential transformer-based LLMs. I think you have used this one. It's widely used for various NLP tasks. So just to see some use cases, real-world applications of these open source models. So for content generation, the Llama actually model is really good. It's created to create marketing copy, product design, description, blog post, and creative writing. For code assistant, the Mistral is really good, actually. I don't know. I don't think a lot of people actually use it, but it's really good. I think you should try it. I think, of course, like it's not as good as the rest of the modules, but for open source, especially for code assist, it's good. It assists with code completion, bug fixes, and automatic repetitive code returns. And for chatbots, of course, the Llama, like for creating powerful chatbots, virtual assistants, and inquire personalized advice and routine tasks to perform routine tasks, you can also use them, which is what actually we're going to be doing for this week. Of course, like as we have said, you can take these models and use them for domain-specific tasks by fine-tuning them and so on. But of course, there are more models that are actually fine-tuned on these particular data sets, or to be used in this particular domain, right? So for finance, interpreting regulatory findings, summarize earnings, forecast market trends, and fraud detections, and so on. Actually, there is a financial analysis, a model that's called FinGPT. I don't know if you have heard of it. Um, yeah, let me just share this screen. So if you can see it, here we have the GPT open source financial large language models. So here it's actually you can read what it has and how to use it and so on. And this is for the finance and for the healthcare. I think there is, sorry. Uh, I think Meditron, yeah. So for medical purposes, we have the Meditron. I don't think this is it. I think this is, think. Why does it only have small commits? Yeah, so this is also open source medical large language model that you can use. It's trained on 70 billion parameters and so on. So you can see it can be used like to analyze patient symptom, automate clinical notes, assist with insurance coding, streamline trials, and so on. So some of them use this to implement a medical, to extract early disease indicators from physician notes. And lastly, for legal, I think a lot of things have been experimented with, but I don't think there is a good enough model that's being used right now. I don't know. Maybe you can do your research and so on, but actually, we also have tried to create, to have this legal assistant chatbot, which is really similar with what you are trying to do right now. But yeah, so for the legal industry, automate document drafting, summarize legal texts, streamline contract automation, and so on. So they can use these fine-tuned LLMs to quickly summarize legal discovery documents. So this is key. Like all these three domains or industries have work with very sensitive data. So the ability to customize and deploy these models on premises is very crucial for sensitive sectors. So that's why, for the examples I have chosen to include these three models or these three industries or sectors. So they are very sensitive. So it's really good to have a model that can be customized and deployed locally or on premises. Lastly, so of course there are some challenges and ethical concerns when considering or when dealing with open source large language models. For, of course, like I've said earlier, for training and deploying these LLMs, it could most of them require substantial computational power. You may need to have GPUs or TPUs and memory, which could cost you which could have high energy costs. Of course, there is a trade-off between model complexity and resource demand. Some of the models that are really good, like DeepSeek and so on, are really like very high or very resource demanding, but of course they are really good. So there is this trade-off. And latency issue with external APIs, the latency is very low. Of course, there is some latency and for local deployment and infrastructure needs, like depending on the the computational power you have, the latency could be an issue. I think that was the main point. And for ethical implications, so for the bias, so if the LLM is trained on unfiltered internet data, it could be harmful. It could have harmful biases or generate undesirable outputs. Misuse, of course, also for all, but the closed ones are somehow mitigated, so they are less, they are less yeah mm, what was the word, influenced by this one. So and of course we have data privacy and confidentiality, so concerns our data leakage, privacy violation, and the need of like audit logs when processing sensitive information also is another ethical implication. Yeah. So open source transparency means models capable of unmoderated response are publicly available, posting explorations, posing exploitation risks. So basically, if the model is not, like guarded, it could be, it could have these ethical implications or biases and so on. So that's actually what I have for the introduction. Is there any question, any concerns, anything that's not clear? Or is it clear? Show me some hands or ask. Okay, let me take that as a yes, it's clear. In that case, I think we can move to the yes, which model we use on low to. Of course, it depends on you. Like we didn't specify in the challenge document because we want you to experiment with the models and work with the one that you want. So it's not limited. Let me. I'm trying. Okay. 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 Any other questions, guys? Of course, it's like I was originally trying to I was planning to use Olama to to deploy it locally and to use it and like to experiment with different models, but I didn't go on with it because I just thought that most trainers could not have or might not have the computational that's needed to do that. So what I did was let me open this window. So what I did was I just go to the Hugging Face and I got my API keys and allowed like for fine grained. I think you have seen this. I'm not sure, but for fine grained on fine grained, I applied or I turned on the fine grained read ability for it and just use that. So here in the aim file, I have the like the API keys. I'm not going to open that, of course. Yeah, okay. I think we can go on and take a look at it. So it's already running. Actually, the StreamNet interface is already running. We will see it actually, but now. So I think I can close this one. Or let it be. Oh. Okay, is that good, guys? I think it was zoomed out a bit. Okay. So let me go through what I did. So let me explain what I've done first. So what I've tried to do is to build a RAG application that's going to, interact with the user and answer the user's question based on the provided document. For this session, I have tried to go to use the famous attention is all you need paper, which I would recommend for you guys to actually read. Yeah, so this is the document that I have used. And the first thing that I did was the ingest. So let me just explain what this function or this script does. So for the database, I have used Chroma DB, which we have seen yesterday. So for the command for the ingestion, so it's going to have take a look inside the documents directory, and it's going to look for .pdf files, and it's going to load them, and it's going to split them or chunk them. So here it has a chunk size of 100, well, sorry, 1,000, and chunk overlap of 2,000. I think for chunking, actually, let me oh, sorry. I can see that there is like this amazing tool that's that shows chunking. What chunking is, like how things change when you change the chunking size and the overlap. Let me share actually this. So can you see this? So here you can see, so for the chunking, like I don't like if like I'm just trying to show this if it is like, you know, if it is a bit confusing for you, for some of you, if the word is like chunking, like things like that is new. So here like you have like basically or mainly you will have three things to choose from, like, or three parameters that you have to choose, or you know, to parameters to now like to change. So here the first one is how do you measure the chunk length? It could be from character counts. If you are if you want to go with the character count, it's going to count the characters. And you have the token count. If you could do it with the code with the token. So let's go with the character count. So the chunk length is the length of the chunk, the one chunk. So here it's going with 200. So here, if I make it 300, I gave it 0, so that's why. Oh, again. So here it's 113. So you can see how the chunk size is changing. So here, what sort of democratization have to fear? And so if I reduce a chunk, it was one chunk, but now it should be like, if I make it smaller and smaller, it should actually change into 2 chunks also. Why is it not changing? Yeah, so when I reduce it to 52 chunk, 52 units or characters, so here you can see that the one sentence have actually changed into 3. 2 actually, sorry, 2. So this like gray one is the overlap. So overlapping unit. So if I increase this one, the overlap between the 2 chunks. So this chunks is part of both this chunk and this chunk. So this overlap. So when I try to change, you know, like the chunk, like the chunk overlap, you will see that a lot of chunks are going to be overlapped. So this is not actually really good because choosing a higher overlap means that it's not going to be it's going to be more intensive, and not ideal actually. So choosing a chunk, an appropriate chunk size is very good. So here you can see which chunk represents which and which overlaps, like the overlaps that you have. If you choose a higher chunk size, so you can see here like it has fewer chunks because the chunk size unit is higher and so on. So, but the overlap are smaller. So yeah, just you can go to this site and experiment with different like chunk size and chunk overlapping, and I think this will help you visualize it and understand it more easily. So that's why I wanted to show you this. Yeah, let's go back to the code then. So here, so that's what the chunk size and chunk overlap actually represents, and it's going to use it. Sorry, yeah, to split and chunk the document. And then I used the embedding for the embedding model. I used the all mini LM, which is actually specified on the document as well. And it's going to create a .chroma.db folder that you can see here. And it's going to create the embeddings. It's going to save the embeddings in it. So here you can see it has the embeddings in it. So this is going to create the embeddings. And then once the embedding is created, I just went ahead and created the app, the Streamlit app that is going to serve as the interface. So here, yeah, so here we have displayed the chat message and history from the app on rerun. So here is the main thing. So here we have the RAG set up for the RAG. So I used the same embeddings. This is very crucial. I think we have also talked earlier, I mean yesterday, because it's very crucial that you embed the query and the document, or like the chunks that you have with the same model. And then I gave it a vector store, which is in the Chroma DB folder, and you will have the embedding functions, which is this one. And for the client, which is the interface, so I used the interface client. Of course, you can use the Hugging Face Hub as well. Here I used, like, I was struggling with the model number because it has a lot of models and most of them were not working. So here for the interface client, I used the DeepSeek AI, DeepSeek V3 model. And for the token, I gave it my token that I have extracted from Hugging Face. And then this is going to be a function that's going to take in the prompt of the user from the interface, and it's going to retrieve from the vector store, and it's going to take the prompt and embed the prompt. So it's going to be docs, and for the context, it's going to have to go to the it's going to go to the vector store and retrieve the context that it has extracted from the vector database that are closer to the embeddings of the prompt, right? I think I made it longer, the explanation there, but yeah. So here is the message for the role. I gave it system, and for the content, you are a helpful assistant. You are following the context to answer the question. So here's the context. So the context is going to be doc plus page content from like the docs are that are retrieved from the vector store for the prompt. Okay. And here we have so role for the, so I gave it I gave the system the context, and for the user is going to have the prompt. So it has, like, for the context, it has the information, and from the prompt, I gave it the question. Sorry, like the context, it has the context from the system as the context, and as a user, I'm going to give it the prompt, which is the question. So here I wanted to have a stream. So here you will have, you will see, you can see stream 2. So here is just it's this because, like, I think we have also talked about this yesterday. It's just to make it feel more natural, right? So it's not anything else. So here I gave it the model, the message, the maximum token. So I had to change this one because it was stopping in the middle of the conversation. The temperature and stream through is just to stream the response. Okay. Yeah. So finally we have, so this is more of for the Streamlit app. So here, if we detect the inputs and the user presses enter, it's going to start the session, and it's going to take the prompt and give it to the content. And here it will actually show thinking. And once it gets response, it's going to take it chunk choices and then give us the response. And here we have the source document. Since it's a RAG application, it's really good to show where the response came from. So that is what the resource is. So here I have an expander. So expander means drop down. So when you click it, it's going to drop down, and it's going to show the source documents that we have extracted from the RAG function. Okay, so it's called the metadata, and it's going to show it, and it will be part of the full response. So that's pretty much it. It's a very simple and lightweight function. Is just compressed of a single, like two, I would say two scripts. It's a very simple one, but I think we can take a look at it in work. So let me yeah, so here it is. Yeah, so this is the chatbot demo, and here, like, so if I ask it, it's going to run. So it's not like excellent, like, but it's going to show you your question, and this is what we mean by streaming. So it's going to give us word by word. Actually, you can manipulate it to be faster or slower and so on. But yeah, so it's going to talk about the document. So it's not going to do talk about anything else. So the process, the document appears to be research paper technical report related to natural language processing, specifically focusing on machine translation and parsing. The key topics discussed are machine translation, process parsing in tree banks, model architecture, and training details. And here you can actually see the resource that's the model based its answer on. So you can see it here, and if it is not a good response, or if the resources are not good, you can actually go back and change the chunk, the retriever. So the mean. So if your model is good and the answer is not good, it's either your prompt, which is argumentation, or your retriever. So the generation. So RAG is three things, right? Retrieve, argument, and generate. So if your retriever, if your generation is good, if the model is good, so it means that it's most probably your retriever, and sometimes it could be your argument or prompt. Yeah, so that's basically it from my side. Okay. Yeah. I think Pandemic had shared the link. Yeah. Okay. Good. So, any questions, guys? Anything that's not clear? Anything for LLMs needs to be over and the closed version cost money. Yes, it worked. That's why I chose to go with the API one. But I was planning earlier, I was planning to do it locally, but like, yeah, I don't think that's going to be feasible for most of us. But if you are interested, I can share, like I can do it with Olama, and yeah, you can check it, take a look at it if you are interested. Yeah, so any questions, guys? I don't know why everyone is quiet. Is my audio not clear, or did you miss anything? Is it clear or is it not clear? Do you want me to go over some things? Yes, Gabriel. Okay, thank you.
Okay, thank you. For this
Yes.
Streamlit, are you using the API or the model?
Model.
Model?
Again, via API. So
I'm sorry. Okay. Hello? Hello?
from Gabriel's side, guys. Gabriel, I can hear you.
Okay.
The answer is my okay.
Your audio is good. I think it's just his audio.
Thank you so much for confirmation. But stepwise. So it's more. Let me try. Okay. Yeah. So this is it, right? But let me explain the first thing the things that I did, and how it adapts to the full RAG application. Okay. So the first thing I did was, so in order to have a RAG application, you need to have the documents, all right? You want to communicate with. So it's just attention, which is the attention zone. You can add a lot of PDFs and ingest this script. What it's going to do is it's going to take a look at the document folder, and it's going to load the .pdf files, and it's going to chunk them up and embed them by using mini LM. And Chroma DB, which is the folder, but I'm also using Chroma DB from LangChain that you can see here. So this is just to prepare the document to be processed in the RAG application. So I think this is basically task, I think task 2 for you guys. Task 1 is cleaning it and, EDA, right? So this is the to do. And then for the first couple of if it isn't RAG application, I use the same the same, like and for the clients, for the which is from Hugging Face, and I use the model DeepSeek with API key that have the main given. So the first one is the retriever. So the retriever is going to retrieving the relevant context based invoke prompts. It's going to take the into a context, and then for the message that LLM is going to have a system. I'm going to tell the system that it's going to be or following the context to answer the question. So, and I'm going to give it the context. And for the user, so which is me, I'm going to give it the prompt. And of course, it's just the stream. So it's just chat completions, since OpenAI, the DeepSeek follows the OpenAI method. It has the chat.completions. Of course, this is different for different models. That you have to understand this is different. So if you plan to go with Llama, or Llama, or if you plan to go with Google, or if you plan to go with what was the name, Mistral, and so on. So they have their own different methods. So you have to go through the documentation and try to read it through their implementations. Okay, but I think DeepSeek I think Grok has moved away. I'm not sure about Grok, but DeepSeek actually follows OpenAI's method. So that's why it's actually it actually was accepted easily, especially in the development community. And it's going to return the stream, which is the stream message, which is the response, and the documents, which is the chunk that is retrieved. Okay. So yeah, basically after that, it's just if the user gives me prompt from the chat input and presses enter or presses send, it's going to start the session message. It's going to append it into the role user, and for the content, it's going to give us a prompt. And you will see here for the assistant, it's going to stream, which is what's going to be responding, right? It's going to return stream in the source documents. Here you'll have the full response, and you will have an expander for the sources, which is called source, and which is going to be include the sources that the LLM used to respond to you. So this is the sources expander, which is just a drop down, which explains or have the context that the LLM used to answer your question. Yeah. Is that clear, Balata? I think. Yeah. Yes, Gabriel.
Uh, what if we included more than one PDF under the documents?
It's okay. It's okay. It will work. It should work.
Okay, like you ask in this case, what is the document about? So in that case, if you ask the same question, does it make any confusion or something?
The answer is going to be concise, but it should have an idea that it's multiple documents and
Mhm.
answer accordingly.
Okay, okay. Thank you.
Okay. Yes, Nabil.
One thing I noticed is a lot of times when you do have your source documents, the better it's structured, you tend to have better results from the LLMs. Just is that based in any kind of truth, or is it actually based, or is it just some observation that's not really supported with how those LLMs work on the back end?
So the more that the documents is structured, I think I missed the first part.
Yeah, so essentially the better the document is structured with clear headers, very logical formatting, that tends to be better input for the regs, enabled for the LLMs to work. Is this based on how those LLMs are working, or is it just something I'm imagining?
To be honest, I'm not sure. Like I haven't experienced that part actually, but it's a good thing. I think I would experiment, but I'm not sure. Like I haven't noticed it.
Okay, thank you.
Yeah, thank you so much. Okay, I don't know if my connection back here it's breaking a lot. So was I breaking up, guys? Why didn't you stop me?
For me, you sound pretty good.
Okay, so maybe it's with you guys. Maybe yeah, good. Thank you, Nabil, for confirming, and thank you guys for. So is everything clear now? Like, but at least do you have an idea of how to do this? Is it clear to some degree at least? Okay, good. Good. In that case, thank you for confirming. Thank you for joining and participating, guys. Thank you so much, and yeah, have a great day and see you guys on Slack. Be active there and answer or ask questions. Okay. Bye.